Hello. Today we're gonna do uh trigonometric proof. I mean, this is not really a year 12 topic, but I found this really challenging question. I'm gonna do it because I think it's a really good question. The question says that sine squared a cos b squared plus cos squared a sine b squared equals 1, and then we have to prove a plus b is equal to pi over 2. And this is what we're going to end up with. So let's just start with this equation. So basically that's just sine 4a cos 2b plus cos 4a sine 2b equals 1. And we want the base to be the same, so we can add them together. So that's just sine 4a sine squared b cos squared b sine squared b cos 4a cos squared b sine squared b is 1. And that makes it so it's sine 4a sine squared b plus cos 4a cos squared b equals, well, these two are just the same base, and then we can multiply it to this side because there's 1 here, so that's cos squared b sine squared a. And then we can make the other side 0, so then that just makes it so it's sine 4a sine squared b plus cos 4a cos squared b minus cos squared b sine squared a equals 0. And then look at all these weird trigs. It's weird to do everything right now, so we might just add some I mean, no, not add some, set them as some variables so they're easier to work with. So basically we want two variables, let's say alpha, because it's a and b, we'll do alpha and beta. And because we have a and b, we'll cos a and cos b, sine a, sine b. Okay, so we do need one of them to be a, one of them to be b, but the sine and the cos. So let's see, there are the same amount of each, but so we can do either. But if alpha have to be a, then there's actually like the same amount. Actually, is that the same amount? Yeah, so we might just make sine squared because we're trying to find an easier way to do it, like a shorter way. But this seems fine. That means to make it easier, we'll cos will then cos squared a will equal to 1 minus alpha, yeah. And then sine squared b will equal to 1 minus beta. And yeah, we can start making our equation into this. So basically that's just alpha squared 1 minus beta plus beta squared no, that's not beta squared. What am I doing? 1 minus alpha squared, and then that's beta minus cos b beta sine a alpha equals 0. Okay, now we can expand it, so that makes it so it's alpha squared, take alpha squared beta plus beta minus alpha, no, never mind. That'll be 1 minus 2 alpha plus alpha squared beta minus beta alpha equals 0. And so that is alpha squared minus alpha squared beta plus beta minus 2 alpha beta plus alpha squared beta minus beta alpha equals 0. Let's see. Well, alpha will stay there. Alpha squared beta, there's a minus, there's a plus. So these two will cancel out. So plus beta, there's a minus alpha beta, so it's minus 3 alpha beta, I think, because there's minus 2 alpha beta. And I do something weird. Yeah, no. Yeah, no, seems fine. I think. Wait, it's. Yeah, no, there's something wrong. Never mind. This is sine B. I was like, where did 3 come from? That won't make any sense. So then that means this will be beta. And then if that is the case, then this will be beta, 1 minus beta. And then this will be minus beta plus beta squared. And then when that happened, there'll be plus beta and minus beta plus beta squared. Is that right? Yes. So then the plus beta minus beta will cancel out. So then it'll be plus beta squared minus 2 alpha beta equals 0. So there's alpha squared minus 2 alpha beta plus beta squared equals 0. So then alpha take beta squared equals 0. And if that equals 0, then we can square root both sides. So then alpha minus beta equals 0. And then that means alpha equal beta. And then that means sine squared A equals cos squared beta B. And so basically what that means is we can still square root both sides. So sine A equals cos B. So for that to happen, it must be 45 degrees because, yeah, so A must equal B must equal pi on 4. That means that A plus B equals pi on 2. I think that's how it works. Or what we can do is basically, because I think that's basically how it works. But then cos B just equals to well, it'll be, because, okay, if we want to turn cos into sine, if we move it to the second quadrant, that'll make it negative, so do we want that? So we want to make it into the fourth quadrant. So to do that, we can do minus pi over 2, I would say. Sine A equals sine B minus pi on 2. So then a equals b minus pi on 2. Wait, is that right? So then pi on 2 will equal to beta minus alpha? I don't think that's right. Wait, if you minus that'd be negative as well. So I think to keep it in the same quadrant, we have to do pi on 2 minus b. Yeah, minus b, and then it'll make sense. So it's pi on 2 minus b, and that means a plus b equals pi on 2, and that still gets us the answer we want to prove. Oh well, that's it for this question. I thought it was really interesting. Alright, bye bye.